Here's another equation that when we look at it, it's a very strange looking one. It has two terms that their variable has rational exponents. They have exponents that are fractions. And that can be very messy to try to deal with. But if we do a little thinking about the relationship between x to the 1/3 and x to the 2/3, what would we get if we squared x to the 1/3? Again, when you raise a power to a power, you multiply the exponents. 1/3 times 2 is 2/3. What we have here is an equation that is quadratic in form. We have this term with a variable and another term that is the square of that variable. And isn't that the way quadratic equations typically look? One of them has x and the other term has x to the square, x to the second power. So this is an equation that is quadratic in form. So we're going to use this substitution approach again. So here I'm going to let y equal x to the 1/3. So wouldn't y squared then equal x to the 2/3? So where I have x to the 1/3, I'm going to put y. Where I have x to the 2/3 in my equation, I'm going to put y squared. That will create a nice looking quadratic equation which we can solve. And again, I chose this so that it's nice and easy to factor, just to speed things up so that we don't have to use the quadratic formula to find the solution. Wouldn't these be the factorizations of that trinomial? And so our two solutions are y equals 3, y equals -1. And now we substitute back. X to the 1/3 equals 3. X to the 1/3 equals -1. And now we would cube both sides to get to x. So I would have x equals 3 cubed is 27. Or I'd have x equals the cube of -1 is -1. And our two solutions that we found are 27 and -1. So let's try one of those solutions back in the original equation to make sure that it really works. Let's try 27. So we're going to take 27 and put it in place of x. Now, the 1/3 power is the cube root. If you have x to the 1/3 power, that's equal to the cube root of x. Well, what about the 2/3 power? Well, remember what that 2 becomes? The 2 becomes the power on the variable, and the 3 becomes the root, becomes the index of the root. So this, taking 27 and raising it to the 2/3 power, is the same as taking 27, taking its cube root, should say it this way, taking 27 and squaring it and then taking the cube root. Or you can actually do it the other way as well, and it's equivalent. We can take the cube root of 27 and then square that answer. Well, the cube root of 27 is 3. 3 squared would be 9. Minus the cube root of 27 is 3. 2 times 3 is 6. And 9 minus 6 minus 3 indeed is 0. So that solution works. And I believe if we tried the other solution, we would find that likewise it also works. So we have two solutions here that are going to work for us for this original equation that was quadratic in form.